Assalamualaikum warahmatullahi wabarakatuh. So today we are from Group 3. We'd like to present the concept and application of mass transfer in the separation process of coagulation and flocculation process. Okay, so first of all, let me introduce my team members, which is Nurul Khairia, Siti Sarah, Nur Zaidatul Adila, and me, Nur Afifah. Now, I will share about the presentation outline for today. So, the first thing first, I will explain about the background of the selected industry, and then the next presenter will share about the chemical process involved in the industry, process flow diagram in the industry, highlight of the separation process in the PFD, concept, process, and the equipment used in the industry, and lastly, compare and contrast the selected separation process with distillation process, gas absorption, or liquid-liquid extraction. So for the selected industry, our group decide to choose wastewater industry as this industry involved in coagulation and flocculation process. Next, I will share a little bit about the background of wastewater industry. So the first wastewater treatment plant was introduced in the early 18th century by Robert Thom in Scotland. The plant used slow sand filters for water purification and distribute the water through an early sewer system to everyone in the country. Okay, so what is actually wastewater treatment? So wastewater treatment is actually a process that used to remove contaminants from wastewater and convert it into an effluent that can be returned to the water cycle. Once returned to the water cycle, the effluent creates an acceptable impact on the environment or is reused back for various purposes that called water reclamation. So the major aim of wastewater treatment is to remove as much of the suspended solids as possible before the remaining water called effluent is discharged back into the environment. So as solid material decays, it uses up oxygen, which is needed by the plants and animals living in the water. Now I will pass to the next presenter for further explanation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sarah. So I will continue about the process flow diagram and chemical process of PFD. So this is the two of process flow diagram of separation process application in coagulation and flocculation. So I will explain more about the chemical process of coagulation and flocculation in process flow diagram number 2. The first is raw water. Raw water will be the raw material, and then we'll continue with the pre-chlorination. This pre-chlorination will reduce the operational issue brought on by biological growth while also controlling flavor and odor during the treatment of drinking water. Next process in PFD, which is coagulation and flocculation. The coagulant will simply adjusting the electrostatic charges of particles suspended in water. And it will also separate the solid from the liquid. Next, the flocculant. By aggregating pollutants into the flake of floc that float to the surface of the water or sink at the bottom, and it will assist remove suspended particle from the wastewater. Next, process, which is sedimentation. It will allow the particle in suspension in water to settle out from the suspension under the effect of the gravity. The sediment or slush is the particle that settle out from the suspension that will enter the slush of the slush drying bed. And then the next process is filtration. In this filtration, we will get the clear water, and it will pass through the different pore size of filter that are made by different materials such as sand, gravel, and charcoal. And the last process is disinfection. By adding any chemical disinfectants to make sure all the remaining bacteria and parasite will kill. And the last one is clear water tank. In this clear water tank, the clean water will produce. So that's all from me. I will pass to the next presenter.
Assalamualaikum, my name is Nurul Herizoni and I will discuss about the concept of coagulation and flocculation process. About the concept, both drinking water and no water treatment depend on flocculation and coagulation process. They offer a dependable method for treating water turbidity, which is a crucial indicator for water quality. Turbidity is defined as cloudiness or haziness of a fluid that is normally imperceptible to a naked eye. They allow for up to 90% reduction in suspended particles and organic loads during wastewater treatment. To overcome the forces that keep the suspended particles stable, flocculation and coagulation are two distinct processes that are used in succession. While flocculation allows the particles to become together and become larger so that they may become more easily to remove from the liquid, coagulation neutralizes the charges on the particles. Moving on to the next slide, which is coagulation and flocculation process. The coagulation itself is a chemical process. The coagulant is added into the water, which is the coagulant is aluminum sulfate, and properly dispersed into the water to promote particle collisions by breaking the particles to release charges and use a rapid mixing method. Their process then led to tiny particles repel each other and promotes their consolidation to bigger ones that are able to stick together. The bigger the particles, the easier it is to separate from the liquid. The equipment used for the coagulation process in industry is metal coagulant, along with the bag mixerator or flash mixer. The flocculation, on the other hand, is a physical process. The flocculant is frequently a polymer that encourages particle settling and eventually develops into larger flake. In other words, the flocculation process is a gentle mixing stage that transforms small, invisible suspended particles known as microflows into huge visible pin flows. As pin flows collide more frequently, they grow increasingly bigger and be called as macroflows. The flocculants help with this by including hydrogen bonding, improve van der Waals forces and entanglement amongst the particles. They also help by being long-chain polymers with low charge. The water is prepared for solid-liquid separation once these flows have grown to their ideal size and strength. Filtration, centrifugation, sedimentation, or flotation may be used for this, as the equipment used in the industry for flocculation process is mechanical flocculator.
Assalamualaikum warahmatullahi wabarakatuh. Now I will proceed with the compare and contrast the coagulation and flocculation process with distillation process. I will compare the two processes based on their purpose of the process, their overall process, and lastly, the application in the industry. Firstly, we can see the difference between the coagulation and flocculation process and the distillation process based on their main purpose. The coagulation and flocculation process are two separate processes used in the succession to overcome the forces stabilizing the suspended particles, and it used to separate the suspended solids portion from the water, while the distillation process is a physical separation based on the vaporization of the different components of the mixture to be separated, and it used to separate the liquids from the non-volatile solids. Now we look up the difference of their process. In the coagulation and flocculation process, while coagulation neutralizes the charges on the particles, flocculation enables them to bind together, making them bigger so they can be more easily separated from the liquid. While in the distillation process, the processing involves the conversion of a liquid into vapor that is subsequently condensed back to liquid form. The coagulation and flocculation is a chemical and physical process, while the distillation is just a physical process. Lastly, we can see that the two processes have their different application in the industry. For the coagulation and the flocculation process, it involves in the effluent water treatment process for the solid removal, water clarification, lime softening, sludge thickening, and the solids dewatering, while the distillation process is involved in the purification of alcohol, desalination, crude oil refining, and in the making of liquefied gas from the air. So I think that's all for our presentation today. Thank you.